Okay, so as advertised, the lesson tonight is about web services. Very useful thing to be able to produce with the Java language. Many commercial companies out there, their software development teams produce web services, web applications with Java, so we want to make sure that you leave with some of that under your belt. So we're going to go into, some of this may be reviewed depending on what other, HTML classes or other web-based classes that you've had. But we'll talk about what a web application is, a little of the history of how this technology has evolved over the years. It's based on the HTTP protocol, if I can spit it out. And so we want to talk about what that is so we all have a common frame of reference when I start using the terminology. And, a little of the differences, we'll get into that, what the nuance here is that I'm talking about between a web server and a web application that runs on the server. Yeah, and there's some other things that we haven't talked about yet in IntelliJ or in the build environment in general. And this is one of the things, as you progress through learning about software development, regardless of what the language is, you'll start realizing that you spend much more time worrying about things that aren't writing code than all this other stuff, dealing with the build system, how you execute the compile and get the artifacts that make up your application, how the application is supposed to be configured on your local machine versus the development common environment, test environments of various kinds, staging environments, production, and depending on the context in which your application is running, it may have very different configuration settings, and the behavior of it may even be very different depending on where it's running and how it's configured. Some of that stuff gets pretty challenging to test when you have no idea in production how it's going to be configured by somebody that isn't even in your office, that doesn't know anything about the code. They're just handling the artifacts and configuring it in ways that maybe you built it for, and maybe you didn't ever even expect that it was going to be configured that way. And then the whole concept of debugging changes when you're working in this kind of a mode where on your local machine, when you're dealing with a simple console application, you can, run it just straight with the play button, or you can debug it and step through the code. But when the thing is running in some data center in Massachusetts, you don't even have access, permissions to get into that environment. How are you supposed to debug it? So you have all kinds of remote monitoring systems that are set up to log events from the server where it's running, and you get a text file that shows you what the events are from your application, and you can't get in there to deal with it or change the configuration. You have to, it's like 3 steps away to even tell somebody what they might try to see if that might fix your application. It gets very complicated. And so you end up spending a lot more time on those kind of issues than you do actually sitting there writing Java code. And so we want to start introducing some of those kind of things from a practical point of view, so that you're not ignorant of it once your first day on the job when you're asked to start being fluent in these things. And unfortunately, like most of my career, you're never sent to a class on how to learn Maven. You're expected after work to go Google it, figure out what it is, and it's very much learn enough to be able to survive the next day at work. And I'm sure you've heard about this, the imposter syndrome, especially if you haven't been working commercially as a software developer yet. Let me just tell you, there's a lot of people out there sitting next to one another that are afraid the person sitting next to them will find out that they're actually a fraud and they don't know how any of this stuff works and they're going to get fired tomorrow. Now, nobody ever does, because everybody feels that way. You're just expected to just dig in, peel the onion away, learn what you need to learn day by day by day. Google is your friend, and, just keep having a learning mindset. You want to have a growth mindset to be receptive to always learning. So I'm going to give you some of this stuff. You may not be given the complete encyclopedic explanation of how a POM file works, but at least you'll see a POM file today, and we'll talk a little bit about how to get it to run in this context with your application that you're going to be writing. You'll get to practice it a little bit, and then the rest is, exercises left to the reader kind of thing. IntelliJ is also deceptively helpful, and I say that, with the nuance that IntelliJ is going to try to do a lot of very smart things for you. That isn't always a favor, because then it does it automatically, which doesn't make you go learn what it just did or how it did it, and what if it had done it a slightly different way. How would that have helped or hurt your application? So we're going to use IntelliJ just because it's so dang convenient, but beware, with great power comes great responsibility. Spring Boot is a framework we'll talk about, and hopefully if we can get it to run, we'll actually make one tonight. Yeah. Okay.
Call it POM file for a reason.
It probably stands for something. I think it's sort of like, like a bill of lading, bill of materials. POM probably stands something like that, but it's essentially the file that gives Maven everything that it needs to know to do what Maven is good at doing, which is assembling all the parts of your application. But you'll see. Or you can probably look up what does POM stand for in pom.xml. It may be an interesting story, it may not be. Okay, so the interwebs. I say that tongue in cheek. I know I'm not a boomer, but I know boomers call it that. But little bit of history, since I do have the gray hairs in my beard, to show how long I've been around dealing with this kind of stuff. When we started out with the internet, it didn't exist, and nobody had ever used the term before, but we had computers, and they became networked together so that they had a way to communicate with one another electronically. So people were experimenting with the first email systems, right? Where you could create a digital file and you could email it to somebody else and it would pop up in their inbox, and they could open that file, save it on their computer on a disk or on printed cards or whatever, punch cards, whatever technology they were using. But we were just beginning to be able to pass data back and forth to one another back then. Still no web browser, still no internet, nothing like that. So they were just passing back and forth text files. And, as the story goes, it was researchers at universities that were wanting to share the data about their research so they could collaborate with one another. Okay. So at some point, it occurred to somebody that, boy, it'd be really helpful if I could mark up my document with embedded little tags in it, and that way when we send it to the printer can print it with bold fonts and italics and all that kind of stuff, which is where markup languages got invented. It didn't look at all like HTML, and we didn't have WYSIWYG, what you see is what you get, editors in which to view the files. Nothing was graphical back then. It was all very text-based. But when you sent it to the printers were built to be able to do this stuff a little bit more fancy. So, yeah, markup languages. Okay, so that continued to evolve, and then hypertext came, because what they wanted to do is they wanted to have multiple of these files, and they wanted to have links from one file to the other. And so you could create, a set of documents where you're reading through there and you have a place where you can click and it navigates to the other file. And so hypertext. And so that was added to the markup language. And you know. Thus, we had a veritable web of interlinked documents, and so that's where the interwebs, the World Wide Web, the internet started, that moniker started being used. But the reason why I go through that is I want to point out that if you wrote, let's say, you know, something we're all familiar with, if you wrote a Python file, where if you execute the Python file, like mypythonprogram.py space, and you gave it some parameters, like let's say you gave it a file name. And when you wrote that Python program, if you wrote it to accept a file name and you open up the file and just print the contents of the file to the screen, you know, very simple program, open file, print the contents. Okay, we can make it a little bit more fancy. We can say, well, if I look for the file and it doesn't exist, I can return file not found. Or maybe I'll even return a number like 404, and that will stand for, I didn't find the file you asked for. You see kind of where we're going with this? So then we sort of evolved, or maybe a 300 number that says, oh, I see the file here, but you don't have permission to view it with your credentials. So I'm going to enter, you know, 300 no access, or, you know, access denied or something like that. That's where all these return code values started evolving. And I guess that's my point is, a web server or a web application running on the computer that we call the web server because it has web applications running on it is nothing more than a program that accepts a parameter of, yeah, what is it you're looking for? And it kind of expects it most of the time to be a text file that contains HTML markup text, or an image, or one of a various number of other supported file types. You give it the name of that file and it will return it to you. And in the beginning of the internet, that's all web servers knew how to do. You give them a file name, they return the file name, because they were just expected to be documents. Okay, then it got more complicated where, well, what if the document doesn't actually exist? But if you give me something that pretends to be the file name, like customerlist.txt, oh, well, there is no file called customername.txt, but you know what? We've got this database sitting over here, and I could send a SQL query to that database, and I could read all the customers, and I could return the list of customers to them as if it was in a file. All right, well, now we're getting a little bit more sophisticated. We're executing some code on the web server to generate the output that we're returning. So let's go back to our simple example. If I was to write this simple Python or Java or C++, whatever, this simple program, and I called it, and instead of trying to look for a file, it just printed to the screen HTML body hello world /body /HTML, and it just returned that string. Well, now we've got a web application. We make a call to it, it returns HTML. I don't have to deal with the whole directories full of files thing. Okay, then now we're talking about something in our world. We can write programs that, given a set of parameters, they can generate and return HTML on demand. And so that's our goal here, is we want to be able to create Java programs that, when asked, they return different kinds of HTML and return it. You know, maybe I give it a city name and it returns the weather report, something like that. Okay. So, you know, then I guess, you know, the browser comes into play because, you know, the person's sitting there asking for the files. They don't want to have to type text in on the command line every time. So we wrote web browsers where you have the address bar, and that's where you type in the address of what you're looking for. It sends it off. And then, you know, you can Google these terms: Common Gateway Interface, ISAPI DLL. These are technologies that evolved, but they're basically just various ways to package the same thing. We're writing some software that generates HTML that when asked, returns the HTML to whoever asked it. Now, if they're doing it from a command line, or if they're using Internet Explorer or Mozilla or some other fancy web browser program to do something interesting with that text that we return to them, well, that's up to them. They can do whatever they want to with it. And that's where the whole web browser evolution came from. But we're not building web browsers today. So I'm going to try to set that part of the conversation aside. We're talking about building web services today. The CGI and ISAPI, all of those are different technologies for opening up a port on the internet, on the network, listening to requests coming in, and then figuring out how to map those incoming requests to the code that we wrote and calling it, getting the response that it prints to the screen, and then packaging it back up and sending it over the network. They're going to handle all the network communication back and forth because that's boring. We're not concerned with that. We want to be application developers, not network programmers, not systems programmers. So if you take a C++ class, networking class as part of your bachelor's or master's degree, you might get to investigate writing C++ programs to deal with port APIs and do actual network protocol traffic back and forth in various ways, token ring and different stuff like that. It's kind of fun. But, most of the time we just assume all that kind of stuff is there and works. It's part of the operating system, or it's part of the web publishing service software that runs on the web server. So IIS is the Microsoft traditional product that runs on Windows computers, Windows servers. Apache Tomcat is the name of the web service that typically runs on Linux machines. You'll hear these terms thrown around, but I'm trying to just give you some high-level context of where they fit into the picture, even though, they're there, they do their thing, but we don't interact with them that much. Alpine, we'll get into that a little bit next time, but Alpine is the name that they gave to a Docker image that somebody built with a scaled down version of Linux that has no fluff, but just the basic components of Linux. And Apache Tomcat needed to have the really small, tiny footprint of web server that we can then add our files to deploy our web application. So you'll want to know what Alpine is and where it fits into the scheme of things. There's lots of other stuff. Browser plugins, again, that's client side. ActiveX technology was in there along the way. WebGL. Lots of things came and went, and some of these technologies, they worked really great, and it's like, wow, this is really clever. The greatest thing since sliced bread at the time. But it's like we keep inventing these technologies and putting them out there, and then somebody figures out how to do them to scam us for all of our checking account. And so we disable those and move on to the next technology. They figure out how to get into that. We disable that and move on to the next. So it's kind of like this cat and mouse game of creating new technologies and waiting for them to get exploited. So lots of things have come and gone that I won't bore you with. But, they're interesting. If you were to go research them, there's some pretty good cleverness that has been done over the years. Okay, so a little bit more specific, the particular conversations that we're going to have with our web browser. So, user types in a URL. There's an example of one on the screen. So this first part, HTTPS, you're going to see HTTP or HTTPS. HTTPS is pretty much the default now. I grew up in a day where most of your URLs were HTTP. And then where you were going to switch over to the page where they're going to ask for your credit card number, then it was HTTPS because you wanted to encrypt the credit card data that was going back and forth. The reason why everything wasn't HTTPS is because the network was so dang slow back then that encrypting it and then unencrypting it on the other side was so much overhead that we wanted to avoid it unless it was absolutely necessary. Well, then the networks got faster, the hardware got faster, to a point where now it's like, well, why not just encrypt everything? So now it's like, well, if I go to a website that's not HTTPS throughout, oh, what are these people trying to do to scam me, right? But, all it means is we're using the encrypted version of the HTTP protocol. The default is port 80. So if you had a colon after the .com and some other port number, some other integer, then we'd be using a different port than port 80. But default for web traffic is port 80. And so what happens is, the URL's typed in and the browser, whatever client application you're using to format and send this request, it says, okay, here's my web address. Let me look up a DNS server and I'm going to send that web address to it and I'm going to get back an IP address. And that's the value that you actually have to connect to over the network to reach the web server. So the IP address and the port number, you have to know that in order to get to that machine. Okay, everything after the slash, well, including the slash, so slash folder, slash page.html, that's the parameter. Like I said, if you're executing a program and you're giving it that parameter, that's the file that I'm looking for over on that other computer. And so it's going to try to take that and look in its default folder for a subfolder called folder in this case, and a file in that folder called page.html. And if it exists, it's going to just open it up and read it and return the data to whoever asked for it. And in the middle there's a bunch of network hardware drivers. You got your network card. Nowadays, it's usually built into your motherboard, so we don't even think about there being a network card. Usually we're talking about, 10 megabits per second minimum, hopefully 100 megabits, and nowadays even gigabits. I remember I was sitting there one day at Microsoft, and our IT person came down the hall, and you get new computers on a rotation at Microsoft. If you've had a computer for 3 years, then somebody comes around and says, hey, we just got a shipment of new computers in, and you're next on the list to get one of them, and they just come and plop it on your desk, and hey, you got a new computer. And so you're always kind of the envy of everybody else when it was your turn and you got the latest new computer. And so for a while, until the next box of computers came in, you were pretty cool. Well, this IT guy came by and he said, hey, I noticed you just got the last batch of computers delivered. Since you've got this really fast computer, can I run an experiment on it? I'm testing some stuff back in the server room. I'm like, yeah, sure, what do I care? I was about to go to lunch anyway. So I go to lunch and I come back, and he has gone in the server room and rewired the routing, the wires in the wall to my desk where my network cable was plugged into. And he had hooked me up to it was the first building that was getting gigabit networking. And my computer was the first one hooked up to the router that did gigabit networking. So I actually get to be the first person at Microsoft that gets to use gigabit. And it was blazingly fast compared to the 10100 stuff that we had been using. It was nice. But nowadays, you can set up your apartment or your house with everything gigabit and it's commonplace. And now, servers and data centers and stuff, they've got the next level. And, our gigabit stuff is like ho-hum. But anyway, a little bit of an aside there. I thought it was cool stuff because I had gigabit to the desktop back then.
Was it?
Yeah,
What year was it?
this would have been about 97, 98. Yeah. Yep. Already said all that, I think. Okay, so if we're going to build a web service, instead of using a web browser, we can use any one of a number of different tools, and we'll play with some of those if we can today, or you can use them on your own. But let's say I use curl as an example because now it's pretty ubiquitous. All of our PCs come with curl installed, and Macs come with curl installed. So it's a common tool for sending URLs to a web server, getting the response back, and just displaying the output on the screen. Okay, so here's one that's pretty cool, I think anyway. Oops. Dang it. If I could figure out how to use my keyboard. Are we back in business? Okay, we're back in business. All right, so let's say this is our URL. This is an actual URL, so if you go to weather.gov, they have an API. Well, weather.gov is a website, so you can view web pages and you can click on things, the hypertext links and stuff, and you can navigate around the page and you can enter stuff in the edit boxes and submit the forms and all that kind of stuff, just like you would any web page. But you can also access their API, which means you're going to be sending web service requests to a program that's written to accept those requests, parse the parameters, and generate HTML to return to you. And so that's what this, or not even necessarily HTML, I guess I should make that point clear. Web services are essentially written to support program-to-program communication. Because just like it's useful for us to use a web browser to access HTML files on a web server, it's also very convenient for us to write software that calls a web server, software running on a web server, to have it generate or look up data and return that data to us formatted in ways perhaps other than HTML. Okay, so that's what this example does. I give it this zone, FLZ 162, which if I remember right, that's the zone for Punta Gorda up where I live. So just like with the web browser, curl, the program curl, is going to take api.weather.gov. It's going to ask a DNS server, hey, what's the IP address for that? It's also going to assume port 80, and it's going to try to connect to that server. Then it's going to pass /alert/ and the rest of it as a parameter to that process, whatever it's written in, running on that web service. And whatever program is running there is going to generate a response and send it back. Now it formats it in this JSON format, which is called JavaScript Object Notation, only because it was developed about the same time that JavaScript was a very popular programming language for doing this kind of software. It's simply just a format. Instead of being a markup language like HTML, it's curly braces and comma separated syntax, which you'll see. Maybe that process on that other server is written in Java, like what we're trying to do. Maybe it's C++, I don't know. That's the point. We don't know, we don't care. All you have to know is the address of the server, the protocol to talk to it, and give it the right parameters, and it'll return what you want to. But it's pretty cool. And curl, instead of formatting it in a pretty graphical way, it just displays it on the screen. And if you want to do that, if you want to write your own programs, you can find out that this API is documented in very much a similar way that we're going to learn to document our web services that we're going to develop. And you can view that documentation and figure out all the other different endpoints that service supports, so you can call them yourself. It's pretty cool. Okay, so I went out and I already did the curl for you, and here is what it returns. You can see this JavaScript object notation formatted output. This has an opening and a closing curly brace, and inside there it has parameters that are blocks of data. It's generally label colon value, label colon value, and those values are comma separated. So it's just a bunch of key value pairs, you know, but pretty nifty. So I can see from this URL that for that NOAA zone, there are currently, or at least when I ran this, there are no alerts active. You know, no hurricanes coming, no severe thunderstorms, no alerts that are out there at the time. So pretty cool. So you could write your own program to get, you know, this data and do whatever you want to with it. Okay, so a little bit more about the HTTP protocol is good to know. There is a format to those requests. The requests and the responses themselves are simply text messages or text format, and this is kind of what they look like. You can think of this as an envelope. It has a bunch of metadata in it that is required to carry out the conversation between the client program and the web service, but it's not rocket surgery. So we have a get, that's the verb. The /example is the parameter that we're passing, the parameter part of the URL. HTTP3 is telling them what rules we need to abide by. The host name is simply the name of the web server that was asked for. And you might think, well, why do I need to give it? Doesn't it know its own address? But the cool thing about that is the fact that you're passing the host name as an example, it's actually pretty useful. Maybe some of you have already done websites and you've worked with web hosts and stuff. But let's say you're cheap and you only want to pay the $9.95 a month for one domain or one site on your hosting company's server. But you want to have half a dozen different websites hosted there. You can actually make the URL a parameter coming in so that even though it's going to the same IP address and port number, you look at that data and you say, oh, this is for cars.com, so I'm going to send that over here and I'm going to look in that folder for all those files. Or trucks.com, I'm going to go over and look in this folder. So you can host multiple, you can pretend to host multiple different sites. Now, some web browsers warn against that because if you think about it, that's a neat little trick. It's clever, but people could probably abuse it, right? You could have a site that is, you know, mysite.com, but pass Microsoft.com and pretend to, you know, maybe that's probably not a real scenario, but you can see how you could get tricky there. And sometimes web browsers put rules in place where they start warning the user, hey, something weird is going on here, you might want to beware. Some other stuff in here, this user agent, the host, user agent, accept, etc. This is what we call headers. So the browser is going to send the verb, the parameters, the protocol, the headers, and maybe even some other data. But it's always going to follow this format no matter what URL that you put in. So you think you're putting it in on the address one way, it's going to parse that out and break it up and send it to the web server like this. And then the web server is going to format a response that looks like this. You know, we usually just see the HTML that comes back, and we don't even see the HTML unless we say view source. We see the graphical rendering of that, right? But what it sends back is, okay, it says, yeah, we're also responding to you in HTTP3 protocol. 200 OK means, yes, I found what you were looking for, and you know, no web servers were harmed during the generation of this output kind of thing. Everything went well, we're good, and here's your response. The content type, content length, and perhaps dozens of other entries like this are response headers. And one of the key ones here being the content length. So whoever is going to receive this response wants to know how much data is there because it's a check value. If it says 138 bytes and you don't get 138 bytes of content, okay, well, something fishy's going on here. Maybe we got a man in the middle and they're monkeying with our response. But generally they will match. And then the text HTML in the character set just tells you what you can expect out of this content. So it all makes pretty good sense, but you know, it's new if you've never seen this before. So you could write your own, let's say Python or C++ or whatever program that receives data in the first format and generates data in the second format. And guess what? You've built a web server. So then web applications. So usually all of that header stuff gets pulled out, and when you're writing the web application, you just get the good stuff. You get the body of the request and process it, and then you produce what you saw there as the HTML, and the web server would bundle that up with the envelope and return it. And usually from a web service, it's data because it's intended to be geared more towards computer to, program to program communication as opposed to web browser to web server communication. So the data is often going to be in either XML or JSON format. It can be in HTML, it can be in whatever format you want. It could be in binary, like if you're returning an image, the response is going to look very much the same, but the body of the message, instead of being HTML like that example, it's going to be a bunch of gibberish looking stuff. It's not actually binary, it's text encoded binary, so they take it and turn it into like base 64. You can Google that, how to do that. It's actually an interesting program I could assign. Hey, I give you some text and you, or I give you, let's say, an image file and you base 64 encode it. There's an algorithm for how you do that. Yeah, the browsers, we've got lots of browsers nowadays. The reason that I do mention the browsers is because we can use the browser to test our code. If you call a web service endpoint that returns JSON or XML, it will process it and it'll show it to you because it was written to be able to support that. But in that scenario, the browser, we're just using it as one of any number of potential tools to test our code. Curl, the one that I showed you, is another example. Postman is a nice one. It's more of a graphical user interface as opposed to working in a command prompt. And so it has lots of cool features, like once you type in a request, it'll save that request so that you can call it again by just clicking on it. A lot of really cool features like that. And then I put this URL there if it still works, but if you just Google for Postman alternatives, that's an easy way to get a list of a whole bunch of other cool tools like Postman that people have developed over the years that have, nifty features of their own. You know how that works. Somebody's sitting at a company and you're using Postman and they say, Postman is great and all, but I wish it did this. So they write their own tool that does what Postman does plus that, and now we've got a new tool. So anyway, but it's good to be familiar with one or more of these things and get comfortable with the features so that you know how to use them when you need to test your code. Yeah, so I think I've already mentioned a bunch of this stuff. You can write your Java program that we're going to be calling a web service, and you can still use it to return HTML or other static content, images and such. It doesn't have to just be generated data. You can make it more flexible. And when we get into these Java frameworks like Spring Boot, we want as software developers to only have to go to one place to maintain our application. So typically you would want it to, the framework to support anything that you want your application to be able to do. And the key is here, we want to get to a point where all of the boilerplate has been configured before we got there. So all we want to do is worry about, here's the parameters that were passed to me, and here's the output that I want to generate as a response. You can think of it as one of our functions or our class methods that we've been developing. It has parameters and it returns stuff, right? And if we can get it boiled down to that, it makes our life as Java developers very easy. So if we wanted to create a new one of these in IntelliJ, here is what the new project screen would look like to start with. Hopefully you can see most of that, but you'll get some practice doing this. But you give it a name just like you do your other Java projects. In this case, I've called it Simple Web Service, but you can call it whatever you want. As you know, when you put this name in here and say next, it's going to generate your code where the package name is going to be something based on Simple Web Service, so it is going to use that name. So you don't want to just use ABC123 as your name there. You want to put some thought into it, but not a lot, Creating the Git repository, as we know, is optional, but I encourage you to put the code that you create in here into Git, just so you don't lose it after this class. You can keep it to refer to on your own later. The next change that I put here is I've clicked Maven in the type, and that's what gives us the POM file, the pom.xml file. And all this means is when you hit the build button, it is going to use the Maven tool, read the POM file, and build your program that way. That's all that means, as opposed to what we've been using. We've got this new thing called group. I've typed in edu.fsw. Typically what this is going to be is like the domain name of the program that or the website that you're working with, but backwards, in reverse. So if I was at Microsoft, it would be com.microsoft and maybe other stuff, .finance or .games or something. But all this does is it's used for the namespaces of your tools. If you're working in a development environment with 50 other software developers, you don't want to be colliding with each other, okay? At the same time, if everybody in your team is using the edw.fsw namespace, you want your software to follow that namespace too. So in that case, you would want it to conform, but that's what that group is being used for. Artifact, that's what my jar or war file is going to be for the artifact that it creates. Package name, edu, fsw, simple web service. As you type these things in, these edit boxes, the other ones are going to automatically update. So you don't have to type all this stuff in every time. It does help you. The JDK, it'll have something selected there just like it does when you're creating your programs. Use some care with what you're using there. I think it's like 17, isn't it, by default for what comes with IntelliJ? But you need to be intentional about that choice, just like you are with your own programs. But as we talked about earlier in the class, you just want to make sure that the one you pick is the one that you intend to use and the one that's installed on your computer and the one that's installed on my computer, so when you turn it in, I can compile and run your program. If you're using a version of the JDK that I don't have access to, then I'm going to have to monkey around with it. And as I say, it's hard to earn full credit when you make your instructor work harder. Anyway, so that's an example. The other thing is, most of the time over here on the left side, you may wonder, where did all these different fields come from? This doesn't look familiar with the projects we've been creating. That's because we usually, under the new project, we pick Java up to this point. Well, I'm using what they now call a generator. And if you're looking at the PDF or the PDF that I put out in Canvas for you to read, or if you're watching those YouTube videos online for tutorials and things like that, they're going to call this a Spring Boot initializer with no E. It's initializer. That's what they used to be called. All of these things over here on the left used to be called initializers. For some reason, they changed the name to generators. So now it's the Spring Boot generator instead of the Spring Boot initializer. But like I said, all of those documents and videos that have been produced 2-3 years ago, they're going to show it as initializer, but it's the same thing. So if you're using IntelliJ now, just pick Spring Boot under generators and you'll see all the fields. They may be slightly different, but I'm confident you can figure it out as to what to enter there. Okay, any questions about that so far? I mean, this is when we're getting into the practical steps for here's what we're going to be doing with this assignment coming up. Okay, so the next thing we're going to add, so just like with our previous Java programs, we learned how to use Java docs so that in the regular course of creating our code, we just had to add some specially formatted comments in our code. And at the end, we use JavaDoc to generate this beautiful API documentation for us. Well, it's a little bit different when you're talking about building web services, okay, but very similar. There's a tool, it used to be called Swagger, that became popular, then dominant, then they open sourced it, and when they open sourced it, they quit calling it Swagger and started calling it just Open API. And it is nothing more than a way to generate documentation about your code automatically based on the embedded comments, and instead of putting it out there like JavaDoc does, this puts it in a part of your web service code. It's actually its own code, so that it has its own URL structure, so that when your web service is on some server running, you can get access to the documentation remotely. So if you own this API, this beautiful weather API that you've created, and you want other people out there on the interwebs to be able to call it, they don't have to call you and ask for help in figuring out how to call it. They don't have to download the latest documentation and scroll through a bunch of PDF files. No, they just ask the web service itself, can you please tell me how to call you? And you didn't have to do anything. All you had to do is configure your project, just like we configured for Java docs. You'll configure your web service for Swagger, and you just build your product. And then once you've deployed it and it's running on a web server, you've got URLs that you can call that'll return the documentation. So similar as we had with our plain old Java projects, you'll be expected to add Swagger to your web service projects. There's a build time tool that does this when we build our product. There's extra build steps that happens. That's one of the reasons why we start doing things like switching to Maven, because Maven can help assemble those other pieces of library code into our code to help us do some of these things. And we like it because we didn't have to write any of it. Yeah, similar to JavaDoc, one of the cool things about this is if you have a function that you want somebody to be able to call over the internet, it's nice to tell them what the parameters are to that function and what the data types of those. Oh no, you pass an integer and a string, not a string and an integer, that sort of stuff. They can see all that right there in the documentation. This last little note here is you need to think about the fact that, and not overshare. Like if you're working for the CIA and the CIA has a web service out there, maybe they don't want their API to be fully documented. I don't know. I'm not the CIA. So maybe they do, maybe they don't, but you are making your documentation public, so obviously what goes along with that is don't share something that's secret that you don't want to share in your documentation. Yeah. And so let's play around and see if we can't do that a little bit.
Like, will this be like our base for the next assignment?
Yes. Okay, so I run IntelliJ, I say new project, I say simple web service. I come down here, I pick Spring Boot. Oh, I guess I have to retype in simple web service. And see, I have all these cool little fields here now. I'll say create Git repository, sure. Language is Java, type is Maven. Instead of com.example, I'm going to say edu.fsw. All this other stuff already populates. It doesn't have a JDK selected, so I have to pick one. Let's just have it download a JDK. Yeah, that's fine. We've had to do this before with every one of our projects so far, so that's nothing new. You know, on your own machine at home, you only have to do this the first time, and then any other web service projects that you create, you can just use the same one. We go next. Okay, now this is the next thing to know. What dependencies do I want? There are hundreds of these things, and well, maybe not hundreds, but at least dozens of these dependencies that you can use. Now, all of this stuff is things that other Java developers that build web service have found helpful in the past. Most of them, well, almost all of these are going to not apply to us at this point, but some of it will. So I'm going to go under Web, and I'm going to pick Spring Web. There's another one under security that we'll play with soon because we want it to work with our Swagger stuff. But the instructions on that will come soon. And I want you to understand that you don't have to pick all, like, I have sat here and I've worried and fretted that I was going to pick the wrong ones or not pick enough of them or pick too many and screw up my project. You don't have to worry so much about it at this point. You kind of need to know where you're going, but you can come in here later and fix this if you mess it up later. You can add additional dependencies later if you want to. So for now, the only one I'm going to add is Spring Web. When I do that, then IntelliJ goes off and it does a whole bunch of interesting stuff for me. How do I make this go away? You got to click on the little automatically to let it give the permissions to your project. See, it didn't used to be that way either. You know, it wasn't too many years ago that you wouldn't get warnings like this for Defender because you would do all your development as admin on your local machine. But, you know, this principle of least privilege is a good idea. So now we don't typically write code as admin on our machines. Just go away. There. It opens this by default, which I don't need. So I'm just going to come over here in the tree. I'm going to open the source folder. I see I've got a main and a test folder here. If I open those up, I've got a Java folder. If I open that up, I've got a simple web service application class. So I'm going to open that. Oops. There we go. Always forget what the shortcut key is to make the text bigger. Okay, so this is pretty simple, right? It's very similar to when we're creating a regular old Java program. I've got a public class and I've got a main function. The differences that I can see right off the bat is it has some annotations on it. So this is annotated with this little ampersand Spring Boot application thing. Okay, fair enough. So there is some kind of stuff behind the scenes that's going to expect my web service application class to have this annotation on it so that it can work in the ecosystem of a web service and all the wiring can be hooked up automatically for me. I don't care as long as I know that it's got the annotation. How that works behind the scenes can be left to another day. But suffice it to say, I've got an application class and it's annotated. Inside that application class, I have a main function and it has to call springapplication.run and tell it, here is the application class that you should expect for this project. Now, if I run it right now, it'll probably work, but it's not going to do anything. I get a firewall, yep, allow access, yep, it's all good. Nothing nefarious is going on here. And then I wanted to show you this over in the little run window. I get a bunch of messages out here, and the important one is Tomcat started on port 8080 with context path /. That's the important bit. So if I go to a web browser window and I type HTTP, not HTTPS, I get white label error page. That's expected. But what it means is, and you probably saw some messages over here in the run window pop up, that means the web browser was able to connect to the Tomcat web server running on this machine, which was able to direct the traffic to my Spring Boot application web service, and ran some code, threw up its hands, and responded. Great. And now that's where we get to the next part of the project, which is how do I make the error go away? And how do I start adding web methods to this project? And all of those instructions are in the PDF file that I put under modules for you to read. Hopefully you've seen it. I mean, the pieces that I'm leaving out here are, okay, version control. I saw there was a git error, so apparently there's something wrong with this instructor machine. But you've done this multiple times now with different Java projects. The part about git is no different. You're going to come down here to the git, the version control tab, and you're going to submit all of the files to your repository. You're going to commit them locally. You're going to push it remotely to your GitHub repository, and good. Okay. So that's not new. But what you're going to do in here, let's see, right click, new Java class, and we're going to create something called Simple Web Service Controller. And the last word, the simple web service part isn't important, but you should call it controller, because that's what we're going to make this, is a Spring Boot application controller class. And the purpose of this controller class is to be the kind of the dispatcher. it's going to be something like Spring Boot controller, Rust controller, something like that. Anyway, the instructions are in the PDF file that I put out there for you. What to do from here. So you're going to end up having at least these two classes for the web service part of the functionality. Then you're going to have another class, because when we take what we've created here and we go back and try to add the Swagger documentation stuff to it, what that's going to look like is, I wanted to point this out to you. If you look over here in the tree of files over here on the left, down near the bottom is this pom.xml file. Let's open that up and look at it. Now, like I said, all this is instructions to Maven to tell it what to go grab and pull in and assemble as all the pieces of this application, to put them all in the same jar file or war file, and that's the artifact that's going to be deployable or runnable as your application. So you start looking through here. I'm not going to give you an encyclopedic delving into all this stuff. Licenses, developer, there's a lot of metadata that you can put into here. It does tell what version of Java this is expected to run with. And then the important bit that I want you to see is this dependencies group. Be careful with it. I have screwed up projects before when these dependency blocks got out of order. Sometimes there's some of those building blocks that need to be included in here in a specific order so that they behave correctly. Just beware of that. If you're using the little wizards and stuff, you usually don't have to worry about it. The main thing I want to point out to you as you're doing your project is this little pop-up here next to dependencies called Edit Starters. Remember when I told you when we were setting that up in the new project window that not to worry too much if you pick the wrong ones or you don't include everything that you need? If I click on Edit Starters, I get that dialog box back. And I can come in here, for example, under Security, and I can pick the Spring Security and click OK. And it added a new block into this group for me. That's all it did. I picked it from the box and it stuck the appropriate one in here. But there's some other stuff to worry about, like I said, which is in the assignment. And play around with it, have fun, use Google, put it in GitHub, and hopefully that's enough. And we'll talk about it again next time. Another thing that I want to point out to you. Remember I showed you in this run window the messages down here at the bottom? And it says Tomcat started. It doesn't say that Tomcat was stopped. All the time while this project is running, Tomcat is running in the background. If I push the stop button up here to stop running this program, now it killed Tomcat. Now Tomcat is no longer running in the background. I should have seen some messages down here. Oh yeah, process finished with exit code 130, whatever that means. If I run it again, I'm going to get a new set of messages. Okay, once again, it's Tomcat started on port 8080. Okay, so if I go and I change this pom.xml file and Tomcat's still running and my application is still loaded, what is running? It's probably the previous build, right? And if I edit the POM file, my artifacts probably need to get rebuilt, don't they? So one common error is to make changes to the code or changes to your configuration without rebuilding and redeploying and rerunning everything. So be careful for that. If you're like, Why isn't this doing what it's supposed to be doing, or why is it crashing? Oh, stop everything, rerun it. The POM file especially has stuff where you need to update its indexes. These things out here, it tries to be very abstract about it. Like when I added this org.springframework.security, there's a version of this that is the latest version of it, and it lives out on the internet. And the people that created that module maintain the various versions of it back through time. And IntelliJ, when you tell it you want to add that dependency to your project, when it builds it, it has to go find the latest version, grab it, and pull it down. Okay, if that changes, since IntelliJ asked where it is, you need to update the IntelliJ's Maven indexes, right? So there's a lot of stuff that it's doing automatically for you that you have to be aware of and give it a chance to update itself every now and then. So pay attention to the little pop-ups and the little indicators and the little warnings. And when you see weird behavior, don't hesitate to dig in and try to learn more. Wait, how does this work, and why did what I just saw, why did that happen? That's the beginning of the iceberg, right? I've showed you the tip of the iceberg sticking out of the water. If you have problems with what's below the water, you'll have to go diving and find that stuff yourself. Any questions? Of course there are. I just showed you how to get started. So, like I said, follow the directions in the PDF file, and hopefully that will get you going. I did want to show you that the documentation for the weather API, because it's a good example, and I can give you an example of what the documentation is going to look like when you do it. Let's see if I can get to the actual documentation. Yeah. Okay. This looks very much like what I would expect Swagger documentation to look like. That's confirmed by the fact that this URL sitting up here at the top says openapi.json. So I'm guessing that the people at weather.gov, whatever language they're writing this in, probably Java, are using OpenAPI Swagger, just like I'm hoping that you guys will learn how to do. So look at this, alerts, active, zone ID. That's the request that I was using that I showed you the example of. If I click on this, it expands and it gives me this extra information. It says the parameter is the zone ID. Well, this part right here is probably what that Java developer wrote as the structured comments inside their web service function code. So all you do is your responsibility is simply to comment your code, and the accumulated benefits from doing that manifest themselves in places like this. The other thing that you get from this, I mean, you get, here's the list of return codes that I could get from this. But there's also where's that button? Try it out. So let's see, what was the FLZ 162? And click the execute button. Pretty cool. So it'll actually call the web method for me running on that web server and give me the response back. It also gives me, if I want to use curl on the command line myself, it'll give me the command that I can call. So let's see, copy. Let's run a command prompt, make it bigger. And so if I run that command, it sends this URL, this request off to the web server, and I get the actual response from that web server back with all this data. You know, again, this is meant for a piece of software to process this data. So it doesn't look pretty like HTML would when it's viewed in the browser, right? Why would I want the curl? Why is that helpful? Well, I might want to have a text file that I keep around and I keep a list of all these useful curl commands, and as I build these things up, if I make some changes to my web service and I want to quickly test my web service, maybe I just put this in a bat file and I run it from the command line, and I can quickly retest my entire web service and all the functions in it. So this can be, there's a variety of flexible ways to create test harnesses for my code, and you know, makes it easier depending on what the work life cycle is for different developers in different environments. Pretty nifty, huh? And all I had to do to get this is add the Swagger dependency and some configuration stuff. Okay? I hope this excites you, because to me, you know, you had to survive through the Python how to program class. You had to survive up to this point on what's a Java program and where do I put the curly braces and the semicolons. And now we're getting to the fun part where I can actually create some cool stuff. My hope is that next we will learn how to do this same thing, but inside a Docker container. And then if we had time, I mean, I have stuff like this set up at my house where my computer sitting on my desk at home is using Cloudflare to essentially backport requests from the internet down to my computer and respond to them with processes just like this, with a Docker container running on my computer at home that I can stop and restart anytime I want to, deploy different Java code to it anytime I want to. And if you can get all the boilerplate down and get through wading through the details of how to get it up and running, you can put whatever software on that you want to, and you're hosting your own web service on the internet. It's pretty cool. In a fairly safe, protected environment, you know, where you can't get abused too bad by the powers that be out there. Okay? So here it is, the project. So to prove I wasn't lying, it's got pretty explicit, you know, create a new controller class named, you know, I tried to be pretty explicit with what you need to do. You will run into problems. You'll probably have to Google stuff. You'll have to figure it out on your own. You know, learn to be a Java developer. Learn to figure stuff out. Sound fun? I hope so. Because now it's getting interesting. Okay.